Hello students, welcome back to today's class on real numbers. Real numbers is very important. Till now we have just learned what are natural numbers, what are whole numbers, what are integers, and from there we are going ahead to learn rational numbers and some more numbers, and then clubbing all these we are going to discuss what are real numbers. Right, my name is Avinash and I am a graduate from IIT Kharagpur. Let's continue today's class. So first of all, in the lower classes we learned what are natural numbers, the counting numbers. You count from 1, 2, 3, 4, right? So all those numbers comes under natural numbers, 1, 2, 3 and so on till. Is there any end for natural numbers? No, they just keep on going till infinity. Next, from natural numbers, just add 0 for this natural numbers, one more element 0, and we will be getting whole numbers from there. We get a whole numbers, and when you add all the negative numbers as well, we get integers. Right? Integers like minus 3, minus 2, minus 1, 0, 1, 2, 3. All these are integers. Correct? From integers, we learned what are rational numbers. Rational numbers, once again, in today's class, let's discuss what are rational numbers. Okay. So, from integers, rational numbers will look like something like 2 by 3, 1 by 4, 2 by 7. Okay. So, all these fractions we can say are rational numbers. And we have few more numbers which are not rational numbers, which also don't come under natural or whole or integers. Those are called irrational numbers. Irrational. This black line tells that it is not coming from integers, but we still have more numbers like rational. We have something called irrational numbers also, and these two, rational and irrational, both together are called real numbers. That means in real numbers we have natural, we have whole, we have integers, we have rational, we have irrational. Clubbing all these, we say we have real numbers. Say, I'll tell you in another way. Natural numbers, let us say this is a circle natural numbers. Extended to 0, we have whole numbers, which is represented with W, this with N. Integers with Z, an extended version to this one, we have Z with both positive and negative numbers as well as 0. Right? From integers, we get what are rational numbers, which we represent with Q. And extended to that, we also have irrational numbers, which we denote with the T. Okay, which does not come under rational numbers. We have irrational numbers T. And now the complete set of all these numbers, are called real numbers, which we denote with R. Right? So let's try to have a small discussion about rational numbers, and then we'll go for the discussion of irrational, and from there we'll try to discuss some applications of real numbers. Right? So what's the first one we're going to discuss about rational numbers? So what is a rational number all about? What is a rational number? A number is said to be a rational number if it can be expressed as P by Q, where P and Q are integers. If it can be expressed as P by Q, something like 2 by 3, something like 3 by 4, something like 4 by 5. Okay, anyway, positive as well as negative. Where P and Q are integers, this P and Q are integers, but one more exception is there, that Q should not be equal to 0. What will happen if Q is 0? It will be like P by 0, like 2 by 0, minus 3 by 0. By zeros are never defined. These are undefined numbers. What is the value of 1 by 0? We don't know. What is the value of 3 by 0? We don't know. These are undefined numbers. Right? So let's move forward for the next one. 1 by 5, minus 8 by 15, 2 by 1. These are the examples. These are a few examples of rational numbers. Okay? You cannot have 2 by 0 or minus 100 by 0 as a rational number. These are not rational, as well as these are not irrational also. Irrational we haven't discussed, right? Even there are numbers which does not come under rational as well as irrational, which is not a defined number. It is undefined. Okay. So let's move forward. Plot the rational number 3 by 5 on a number line. Till the lower classes we learned what are rational numbers, right? What are rational numbers? I mean to say, what is a number line, how to represent numbers on number line, how to represent natural numbers, how to represent whole numbers, how to represent integers. Now let's discuss about 3 by 5. So what to do for 3 by 5? As 3 is less than 5, as 3 is less than 5, okay, if you can remember from the fractions, this value will be a value between 0 and 1, because the numerator is less than denominator. So this number will always lie between 0 to 1. Any number of that kind. You can take 100 by 10 or 1000, 100 by 1000. Numerator is less than the denominator. It is always a value between 0 and 1. Positive. If it is negative, 0 and minus 1. Okay, so let's try to take 0 here and let's try to take 1 here. So 3 by 5 will lie somewhere in between 0 and 1. Will lie in between somewhere between 0 and 1. Okay, so plot the rational number 3 by 5. Now what you do, between 0 to 1, divide into 5 parts. Between 0 and 1, divide into 5 parts. First part, second part, third, fourth, and that is the fifth part. 1, 2, 3, 4, and that is the fifth part. Understand? So now out of these 5 parts, we have to take 3 parts. We need to take 3 parts. Or you can write like this. This is 0, right? 0. So this is the first part out of the 5. So this is 1 by 5. This is the second part, 2 by 5. The third part, 3 by 5, 4 by 5, and the last part, 5 by 5, which is equal to 1. Right? So where is 3 by 5? In between 0 to 1, if you divide that into 5 equal parts, you get the value 3 by 5 here. You get the 3 by 5 here. So this is the place of a 3 by 5. Right? Okay. Let's move forward for the next question. Plot the rational number minus 3 by 7. Once again, 3 is less than 7, correct? Positive or negative, that we'll see. But 3 is less than 7. So numerator is less than denominator. It is enough to say that it is a number between 0 and 1. But as we have a negative number, it is a number between 0 and minus 1. We have a number between 0 and minus 1, correct? Okay, let us give more place to write this one minus 1 so that we can keep how many parts we want. Okay, minus 1. Between 0 and minus 1, now we need to divide into 7 parts. Okay, so 1, 2, 3, 4, 5, 6, and this is 7th part. Okay, so this is 0 by 7. This is a minus 1 by 7. This is minus 2 by 7, minus 3 by 7, minus 3 by 7, minus 4 by 7, minus 5 by 7, and this is a minus 6 by 7. And the last one will be minus 7 by 7. The last one is a minus 7 by 7, which is minus 1. Now, where is the rational number minus 3 by 7? From 0, 3 parts together. So this is a position of minus 3 by 7 on a number line. So the point is, you need to understand in between which values your value will be existing and try to divide that into 7 different parts, and from there you need to take a third number. You need to take the third position. Third position is minus 3 by 7. Come from 0, not from the other side. Alright, so let's move forward for the next question. Find any 3 rational numbers between 5 and 6. How to get rational numbers between 5 and 6? So what I'll write, I know between 5 and 6 there are many numbers, but it's very difficult to write. So I'll make it so simple. 5 and 6, let us try to make it as 50 by 10 and 60 by 10. Both are same, correct? 50 by 10 and 60 by 10, it is equal to 5 and 6. So now between 50 by 10 and 60 by 10, I can write many numbers. How can I write that? 51 by 10, 52 by 10, 53 by 10, so on till 59 by 10. All these numbers are the numbers between 50 by 10 and 60 by 10, or simply 5 and 6. These are the numbers between 5 and 6. correct? And you can take any three numbers from there. So let's take any three numbers, 53 by 10, 57 by 10, and 58 by 10, or 59 by 10. So all these are the numbers in between them. All these are the rational numbers between them. Not only this one, you can also write 50 by 10 as 500 by 100. 500 by 100, and you can write 600 by 100, and here you have a lot many options. You can go for the numbers in between them as 501 by 100, 502 by 100, 503 by 100. So all these are the things, right, in between them till 599 by 600. In that way, you can write unlimited, infinite numbers, infinite rational numbers in between any two rational numbers. Correct? Okay. Let's move forward for the next one. Find any three rational numbers between 3 and 4 by mean method. By mean method, which is very important. So, what is this mean method? What is this mean method? Okay, mean means something like average. You can just relate, although these two has two different meanings later. Okay. But for now, you can try to remember as average of two numbers between 3 and 4, right? I'll give you a small example first of all. Between 2 and 4, to get the number between them, we can do 2 plus 4 by 2. What is 2 plus 4? 6. 6 by 2 is 3. So in between 2 and 4, we have a number 3, which we can get from the average of those two. If we have two numbers A and B, the mean A plus B by 2 will always be a number between A and B. The number A plus B by 2 will always be a number between A and B. Correct? So we have a rational number between 3 and 4. So we have 3 plus 4 by 2. 3 plus 4 by 2. So 3 plus 4 is 7. 7 by 2. So this is a number between 3 and 4. 3, 7 by 2 and 4. If you need one more number in between 3 and 4, you can simply find a number between 3 and 7 by 2, correct? This is one number, done. But how many numbers we have? We need 3 numbers. We need to have 3 rational numbers. I told you again, in between these two numbers, we can try to find one more rational number. So that is again using the same mean method. Between these two, you can try to find 3 plus 7 by 2 by 2. And between these two, you can try to find 7 by 2 plus 4 by 2. So these are also the numbers in between them. Okay. So 3 plus 7 by 2, you need to take LCM. Let's try to do that. 3 plus 7 by 2 by 2. So this one, LCM is 2. So it becomes 3 to 6. 6 plus 7 by 2. 6 plus 7 is 13. 13 by 2 by 2. 13 by 2 by 2, which is 13 by 4. The 2 gets reciprocal, becomes 13 by 4. In the same way, let's try to find what is this value. 7 by 2 plus 4 by 2. 7 by 2 plus 4 by 2. Okay. So again, LCM is 2. So 7 plus 4 2s are 8 by 2. 7 plus 8 is 15. 15 by 2 by 2 will give you 15 by 4. 15 by 4. So what are the numbers that I can write between these two numbers? Starting with 3 and 4, we got a number between these two, which is 7 by 2. And again, between 3 and 7 by 2, we have the number 13 by 4. And we have one more number, 15 by 4. And in that way, you can try to write as many numbers as you can using the mean method. Once again, you can try to find a number between these two, between these two, between these two, between these two. Right? Again, you get lot many numbers. You can find infinite numbers in the same approach. Right? Okay. Let's move forward for the next question. The mean method is always says that A plus B by 2 is a number in between A and B. A plus B by 2 is a number between A and B. Right. Let's move for the next question. Express 7 by 16 as and 2 by 3 in decimal form. Now we are going to discuss about decimal. We discussed in the lower class what is decimals. Once again, let's try to have a recall of that. Decimals means we need to divide. Okay, we need to express that as some decimal points. Let me tell you about 16 by 7. 16 and 7. So when you divide this one, you cannot divide 16 with 7, right? So you need to have one more 0 because it is less than 7 is less than 16. Keep 0 point. If you keep point, you can keep 1 0 here. If you can keep point, you can keep 0 here. So 16 fours. 16 fours are 64. 16 fours are 64. So how much is left? Again, we're left with 6. Again, as we already kept one decimal, no need to keep that again and again. Just go with the 0. 16 fours are 64, so we cannot use that. 16 threes we can go. 16 threes are 48. We are left with 12. So I'll give one more 0. So now we need to be careful. 16, how many times? 16 fives, 16 6, 96, 16 sevens, 6 7s 42, 7 1 7, 8 9 10 11. 16 7 is 1 1 12. 16 sevens is 1 1 2, and again we are left with 8. So it is 0, 16 and 80. Do we have any value? 16 fives. 16 5s 30, 5 1s 5, 6 7 8. 16 5s are 80. 16 5s are 80, so we can say that 0.437. 16 5s are 80, right? 0.4375 is the value of 7 by 16. Now let's go for 2 by 3. Let's go for 2 by 3. It's a very interesting question. Okay, 3 and 2. Correct? Again, you cannot divide. You cannot divide. We need to bring 1 0. So keep a point here. So 0 here. 3 6 are 18. 3 6 are 18. So we're left with 2. We're left with 2. Again, 3. Once again, we need to keep 6, or you can keep 0 first of all. So 3 6 are 18 again. 3 6 are 18. Once again 2. Again 0. So 3 6 are 18. And this process will continue so on. So the answer for this 2 by 3 is 0.6666 and so on. It will never end. So can you carefully see some difference between these two? 0.4375, it got stopped there. We got the remainder as 0. But here, even if you go for the next 1 lakh steps, 1 crore steps, you still get the same 6. It is the same 6 being repeated forever. You cannot stop that. Okay. So what happened? Here it stopped. Here it didn't stop. So based on that, we can say decimal numbers of two kinds. One is a terminating. Terminating means it is stopping. Just like the definition which we just saw. It is stopping there. But here non-terminating, just like 2 by 3 value, 2 by 3 value which is a 0.6666 which goes on forever are called non-terminating. Terminate means to stop. The word terminate means to stop. Here it is, there is a stop. Here there is no stop. It continues forever. So decimals again we can classify into two terms, two types. One is terminating. One is non-terminating. Terminating and non-terminating. Correct? So every rational number can be expressed as a terminating decimal or a non-terminating recurring decimal. Non-terminating, recurring means keeping on coming. The same value is keeping on coming, right? That is what we say recurring. Every rational number, just like 2 by 3, or you can have 1 by 2. It is a 0.5. 1 by 2 is 0.5. A rational number can be expressed as a terminating or non-terminating decimals, right? So let's move ahead to see some more applications. A decimal number is said to be terminating decimal if the decimal number contains a finite number of digits after the decimal point. Just now we discussed one example. What is that? What is the value we got? 0.4375, correct? 0.4375. 0.4375. So how many digits we are having after the decimal point? After the decimal point, we have 4 digits. It is a finite value. But if we have something like this 0.5666 and so on, it is never terminating. It is called this is non-terminating. This is not terminating. We say them as non-terminating. Okay. 0.548 fixed. 1 2 3 4 5 6 7. 1 2 3 4 5 6 and 7 digits after decimal. It is fixed. It is a finite value. It is terminating. It is terminating, but here it is never terminating. It is just keep on going on that. Right? Let's go for one more. A decimal number is said to be non-terminating. A decimal number is said to be non-terminating if the numbers after decimal continues endlessly. A decimal number is said to be a non-terminating if the numbers after the decimal continues endlessly. It is just keep on going. It is moving on like this. Endlessly, right? You can say 0.56669766683, whatever the flow it is a non-terminating. It is a non-terminating decimal number, correct? Right. So let's try to move forward. Now let's try to discuss about decimal numbers again, where we have few things: recurring and non-recurring. We discussed terminating and non-terminating, correct? Terminating means there is a stop. Non-terminating, there is no stop. But there is some more information ahead of this one, which is called recurring and non-recurring. Let's try to have small discussion on that, and then we'll stop the lecture. Okay? Recurring and non-recurring. What do you mean by that? See, some cases where recurring decimals are also called as repeating. Can also be called as a repeating decimal. The name itself says that it is repeating. Careful check here. 48, all 4 8s, right? It's the same 4 8 is being recurring or repeating. 4 8 is recurring, right? So this is the number where we can write this as 0.548. Instead of writing all the 4 8s, we keep a small bar like this. 0.548 bar. This bar represents that we are continuously going with 448. We are not stopping anywhere. Okay, the bar represents it is a repeating, or we say recurring decimal. So by this time you might be knowing what is a non-repeating, which does not have any fixed recurring pattern, any fixed repeating pattern, right? So what is that we are having here? A recurring decimal is a decimal number in which a group of figures is repeated infinitely. Group of figures is repeated infinitely. One second. Group of figures is repeated infinitely. You can see here 48 is being repeated. This 0.548 bar. 0.548 bar. Correct? So let's move for one more. Let's try to move for one more, and let's try to see what is a non-recurring. We just saw recurring, which has some fixed pattern which is being followed again and again, but here which no group of digits are repeating endlessly. It is a recurring, that is okay. It is a recurring, okay. A non-recurring decimal is a decimal number in which no group of digits are repeating endlessly. Okay, you can see the examples here. Non-recurring decimal numbers can also be called as non-repeating numbers. You can see here 0.548, 4579982366, some 484579. There is no pattern. We cannot write as a recurring decimal. We cannot have a recurring decimal part. So these type of numbers are called non-recurring decimals. We discussed terminating and non-terminating. We discussed recurring and non-recurring decimals, right? So in the coming classes, we are going to discuss some applications based on this recurring, non-recurring, terminating and non-terminating numbers, and then we are going to discuss about irrational, and then club together we are going to discuss about real numbers, right? Thank you so much, friends. Stay tuned to get the next lecture. Thank you.
Yeah, hello everyone. So today we'll be discussing about circular motion. What is circular motion? Motion along a circle, motion on a circle, or along a circular path is circular motion. Simple, right? Yeah, we'll be learning about it. We'll be learning about the velocity in circular motion and everything else. Okay, so my name is Shashin Reddy. I'm a graduate from IIT Dhanbad. Let's continue. So here when we talk about a circle, this is a circle. It's a very simple shape. So there are some special properties of circles, yes or no? What are they? One is the center. Every circle has a center. And the distance from the center to any point on the circle. You can take here, you can take here, you can take here, here. Any point on the circle is equal, and what is that called as? It is called as radius. I'll use small r to show it. What does that mean? R here is radius, and the length of radius is always equal in a given circle. So here if it is 10 centimeter, that means here also it is 10 centimeter, here also it is 10 centimeter, 10 centimeter and 10 centimeter. Obviously, if you have the radius, you can get the perimeter, which is 2 pi r, or the circumference 2 pi r. You can also get the area using the formula area of a circle. Area of a circle is pi r square. But our concern is not about area here, but circumference formula is important. Circumference of a circle, what is that equal to? Yeah, circumference of a circle is equal to 2 pi r. What is pi? Pi is just a constant whose value is 22/7, or in terms of decimals it is 3.14. That's it. That is what pi is. Simple. Okay? Okay, good. Now, there is one more important line, as you can call it, which is very important. Now, what is that? That is something called as tangent. We learned about radius. Now, there is something called as tangent. What is a tangent? Tangent at any point on a circle is a perpendicular to the radius drawn at that point. That means this is a diameter, this is also a diameter, or we can say from center to this point. If I take this point, what is this? If I call CA, CA is radius, CB is radius, CD is radius, CE is radius. Yes or no? Now, tangent at a point on a circle, let's say if I take it at A, tangent at A on the circle is perpendicular to the radius drawn at that point. So at A we know what is the radius. At A, CA is the radius. CA is the radius. So the line which is perpendicular to that radius. So here this line here is perpendicular to CA, perpendicular to radius at that point. So that line is what? That line is the tangent. It's called as what? The tangent. Obviously you can extend it in this way also. You can extend it, doesn't matter. Okay, so this line which is perpendicular to radius is the tangent. Here also, see at B also, this is radius, this is what? Tangent, and the angle between them is 90 degrees, or tangent is perpendicular to radius. Similarly, you have it at D, you have it at E. So at every point we can draw what? We can draw a tangent. Clear? Simple enough? Okay. Now there is another way to define tangent. What is that? I'll show it to you. If this is a circle, okay, I'll just say a rough diagram. Now at this point you can draw many lines. You can draw a line in this way, you can draw a line in this way, you can draw a line in this way. Now here I have drawn 3 lines, line 1, line 2, line 3. Now look at line 1, okay, let me extend the line 1. So line 1, at how many points does it pass through the circle? Only look at line 1, this is line 1. It passes the circle at 2 points, here and here. If this is A, line 1 is passing it at A as well as at B. 2 points. Yes? Now look at line 3. Line 3 is also passing it at, let's say this is D and A. But if I look at line 2, line 2 is passing through the circle only at a single point, which is A. And line 2 here is the tangent. Obviously, it is going to be perpendicular to the radius. This is what? This is radius. Now, what does that mean? That means you can also define tangent in this way. How? Tangent is a line. Tangent is a line that passes through only a single point on the circle. That passes through only a single point on the circle. Simple. That passes through only a single point on the circle. Very simple. Right, so tangent has two properties. One, tangent is perpendicular to radius. Two, tangent passes through only a single point on the circle. Clear? Okay, that's good. So let's go into a simple question then. Which among the given lines is a tangent at that point? What are the lines? These are the lines. So A, B, C and D, we have 4 lines. So which is the tangent at this particular point? Let me call that point as P. What is the tangent? A, B, C or D? What is that going to be? That's obviously what? That's obviously here the answer is B. B is the tangent. Now you might ask me, sir, why B? Because let us extend B. When I extend B, even when I extend B, it is passing through only the single point. Which point? P. That's what we need. But if I look at A, you might think, sir, A is only passing through one point. But you have to extend it. So when you extend A, it is the line A, it is passing through P as well as another point here, Q. C also is passing through 2 points. Let's say PQ, it is passing through P and R. And D obviously is passing through P and S. Right, so here A is not the tangent. When extended, it is passing through 2 points. C 2 points, D 2 points, but B is only passing through a single point. So B is the tangent. You can say B is the tangent. Now tangent will be at different points. Tangent at which point? At point P. B is the tangent at point P. Simple. Clear? So once again, when we look at a circle has some important points. One is the center, then you have radius, right? And then at every point we'll have what? We'll have a tangent also. This is what? The tangent. In fact, every point has its own tangent. Every point has its own tangent. You can draw a tangent here also. The tangent will be something like this. Right? At every point you can draw a tangent. But at every point you'll only have one tangent. Yes? So that is the interesting point. Okay. I'll just skip it. Clear? So that is tangent. So we know about radius, we know about tangent. Sir, why are we learning about tangent? Because we have to learn about circular motion. Yes, you will understand the importance of tangent within a few minutes. Right? So let's go into a simple question here. Now this is regarding motion. The question is this: if the direction of motion, direction of velocity, so if the direction of motion changes, is the object accelerating? Yes or no? I'll again repeat the question. If the direction of motion changes, is the object accelerating? Yes or no? What do you think? Yeah, yes or no? Quick, think about it. Direction is changing, not the values, not the speed, direction. The answer is yes. Why? Because we know velocity is a vector quantity. What does that mean? That means that velocity has both magnitude and direction. Right? And what is acceleration defined as? Acceleration, I'll just call it as A, is defined as rate of change in velocity. Rate of change in velocity. Look at this. So whenever velocity changes, there will be acceleration, because acceleration is the rate of change in velocity. Simple. Yes. So when can velocity change? Velocity can change when its magnitude changes. That is, the speed increases or decreases. Or when the direction of velocity changes. So if direction of velocity changes, velocity itself changes. And if velocity itself changes, there will be an acceleration. Simple. Got it? That is the reason why the answer is yes. Understood? Okay. So direction is also very important. Okay? Okay. Let's continue. So now we'll come into circular motion. What is circular motion? When an object moves along a circular path, the object is said to be in circular motion. You can see a very simple example here. You have a car, a toy car, you can think of it, a car moving on a circular road. The path is a circle, so in which motion is the circle? In which motion is the car? The car is in circular motion. Because the path is a circle. If the path is a circle, then what that means that the car is in circular motion. Clear? Okay, wonderful. Simple. Now let's again go back into shapes. Okay. There are a few questions through which we'll understand what is the direction of motion or direction of velocity in a circular motion. For that, let's go into a few questions. So what will the direction of an object moving along a rectangle be? So if an object is moving along this rectangle, I'll call the rectangle as A, B, C, D. Then what will we tell what will the direction be? It's very simple. It depends on the side it is going. So when it is going from A to B, its direction is upwards. When it is going from A to B, what is the direction? Direction is upwards. Yes or no? If it is going from B to C, how will the direction of velocity be? Right. Good. Then if it is going along C to D, then how will the direction be? Downwards. Or if it is going from D to A, it is going from D to A, it will be leftwards or towards left. So you have four different cases: A to B, B to C, C to D, and D to A. Now you might think, sir, why only in this way? This is clockwise. It could be anti-clockwise also, it could be anti-clockwise also. Okay, it depends on how we take it. But the point here is all the directions possible, upwards, towards right, downwards, and towards left, are nothing but they are along the sides of the rectangle. So which direction is possible? I can simply say direction is along the sides of rectangle. Yes or no? Along the sides of rectangle. Clear? Simple? Good. So we understood for a rectangle. But what if we have a polygon? Multiple sides, okay? For rectangle you have 4 sides. But let's look at this shape. Similar question. What will the direction of an object moving along a polygon be? Now how many sides do we have here? So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think it is a decagon, right? 10 sides, so it will be what? It will be a decagon. Now here, what is the side? What is the direction? So if I start from here, A. So if we are going from A to B, it will be towards right. If I am going from B to C, it will be along BC. C to D along CD. D to E along DE. E to F along EF. F to G along FG. G, A, B, C, D, E, F, G, H, I, H, right? Yeah. Right, so here it will be along GH. Then you have I, it will be along HI. You have J, then it will be along IJ, then it will be along JA. Right, along AB, along BC, along CD, along DE, along EF, along FG, along GH, along HI, along IJ, along JA. That means here also we can say that direction will be along the sides. Direction will be along the sides. Right? Along the sides of polygon. Simple? Okay, so here also we got the same statement along the sides of rectangle. Here we got along the sides of polygon. It will depend on the shape. So direction will be along the sides of the shape. Simple in the case of a polygon. Clear? So just remember this point. Based on this, we will find out the direction in circular motion. We will go into that. So here again coming back, how many times, now look at the question. How many times does direction change when an object completes one full polygon? Polygon shown here. Now again, how many number here? See, direction, let's say. It changes once here, then twice, then thrice, then 4 times, then 5 times, then 6 times, then 7 times, and 8 times, sorry, 8 is here, 8 times, 9 times, 10 times. It is equal to the number of what? Number of sides. So how many times does it change? Direction changes n times. Direction changes n times. But what is n? N is equal to number of sides in the polygon. N is equal to number of sides in the polygon. Simple. Yes? So that's it. So another interesting point. So in a rectangle, how many times does the direction change? 4 times because it has 4 sides. In a pentagon, 5 times. In a triangle, 3 times. So how many times does the direction change? It depends on the number of sides. It is equal to the number of sides. Obviously in one full rotation. Okay? Okay. So just understand 2 points that we have learned. One is this. For a polygon, direction will be along the sides of polygon and it changes n times. Simple? Okay. Now look at this. So look at the animation here. There will be an interesting animation. Just look at that. It will start again. Just a minute. So it will start again. I'll tell you when it starts. It starts. See? Triangle, square, pentagon, hexagon, heptagon and all. Right? So as the number of sides increase, we are getting what? We are getting a circle. Yes or no? See? Again it will show. From triangle to a square, square to a pentagon, so on and so on. 3 sides to 4 sides, 4 to 5, 5 to 6, so on and so on. As the number of sides increase. The number of sides increase, then what's happening? Yeah? We get a circle. So in fact, how many sides does a circle have? In simple terms, you can say it has infinite sides. It's a different analogy. It's just a comparison. So we can say that, in a way, we can say that circle is a polygon of infinite sides. Huge, many number of sides. Right? And we have seen in a polygon, what is the direction of motion? Along the sides. Right? So here, you can see the side is becoming very small, 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 small. So for a circle, at this particular point, at any point, I'll just show it to you. For a circle, if I take a circle, that's not a circle. For a circle, if I take at any point, if I take at this point, if I need the direction of motion, I need the direction of the side at that particular point. The side will be something like this. Yes or no? So if I draw a tangent will give us what? Will give us the direction of motion. See here. At every point you can draw the tangent. So how many tangents do you have? You have infinite tangents. Same as circle having infinite sides, you have infinite tangents. You can draw any number of tangents because at every point you have a tangent. So that is the beauty of a circle. So in a circle, you can say that a circle is made up of infinite sides, or it is a polygon of infinite sides. Right? So it will have infinite number of directions possible. So what is the direction then? It will be along the tangent. Clear? Understood? Okay, that's good. So here coming back, direction of velocity in a polygon is along the side of the polygon. For polygon that is the case. But for a circle it is along the tangent. For a circle it is along the tangent. And when we say direction of velocity, we mean direction of motion. Both of them are the same. Direction of motion or direction of velocity. Clear? So that is the reason why we learnt about tangent. Because in a circular motion, direction of velocity will be along the tangent. A very important point. Got it? Okay, let's continue. So you have a simple question here. A boy is rotating a stone tied to a string in a circle. Okay, it's like, just imagine. There is a stone, you are tying it with a thread, and you are rotating in what? You are rotating it in a circle. So in which direction does the stone fly off when the boy lets go? I mean, he leaves the string. So in which direction does the stone fly off? Along the radius, along the tangent, or we cannot predict. What is that going to be? Can you think? Imagine the case, okay? Imagine the scenario. So you are taking a stone, tying it with a string, and you are rotating the string. You are rotating the stone in circular motion. So when you leave the string, when you let go of the string, in which direction does it pass through? Does it fly away? Along the radius, along the tangent, or cannot predict? Yeah? The answer is what? The answer will be along the tangent. Okay. Now how I'll show it to you? It's not here. So, if this is a circle, okay, at every point, at any point, you can take this point. At this point, how will the velocity be? It could be something like this, along the tangent. Obviously, if it is being rotated in clockwise direction, then it will be in this way. If it is rotated in anti-clockwise direction, it will be in this way. So it depends on how you are rotating, this way or this way. Okay. So what we will do is we'll take it to be in, let's say, anti-clockwise. So this is the direction of velocity. What is that? Direction of velocity. Okay. So this way you can take it at any point. It will be what? It will be along the tangent. So here, if you are, let's say this is a stone, and you are rotating it by tying it with a string. Now at this point A, if I leave the string, what happens? You left the string, so this stone will fly off in the direction of velocity. Its velocity is along the tangent, so it will go along the tangent. It will go in this direction. It will go straight. In fact, if you leave it here, it will go in this direction. If you leave it here, it will go in this direction. If you leave it here, it will go in this direction. It will go along the direction of tangent, along the direction of velocity. Clear? Because that's how the velocity is. The direction of velocity is along the tangent. Okay? Okay, that's good. Now, an interesting question. A very interesting question, by the way. What is that? Does an object in circular motion accelerate? Yes or no? Does an object in circular motion accelerate? What do you think? Yes or no? I'll give you the hint. Focus on the direction part. In fact, everything we have learnt. Whatever you need for this answer, we have already learnt. And the answer is, by the way, the answer is yes. Now how? We told you, right, if direction changes, we looked at this question, if direction of motion or direction of velocity changes, there will be an acceleration. Yes, so here in circular motion, in circular motion, if you look at direction of velocity, it is along the tangent. So let's draw it in this way. Let's say it is in anti-clockwise. Then at every point the velocity keeps on changing. See, if the point changes, the velocity is changing, yes or no? The velocity is along the tangent, so tangent or the point keeps on changing. So clearly you can see that velocity or direction of velocity is changing. Direction of velocity changes. That means, or this implies that if direction is changing, there is an acceleration. Acceleration will exist. Because if direction is changing, velocity is changing. If velocity is changing, there is an acceleration. Clear? Okay, that's so coming back, we have a special case called as uniform circular motion. As I told you, what does uniform mean? Uniform means constant. So constant circular motion. Thing is, in circular motion, as we have seen here, direction cannot be constant. Direction of velocity cannot be constant. So what will be constant here? Yeah, speed can be constant. So here, for example, if I say there should be some speed. So here if the speed is 10 meter per second, here also it could be 10 meter per second, here also 10 meter per second, here also 10 meter per second, right? So on and so on. So at every point, if the speed is constant, if the speed, only the speed, the magnitude of velocity is constant, what do we say? We say that it is uniform circular motion, or a circular motion in which speed remains constant. Simple. Best example, you can clearly see an example here. Moon revolving around the earth. It revolves at constant speed. Moon revolves around the earth at constant speed. That is the reason. Okay. So, and if speed varies in a circular motion, varies will mean changes in a circular motion. If speed changes, it is what? Non-uniform circular motion. If speed remains constant, it is uniform circular motion. So this is a very important point. So please remember this. As I told you already, what does uniform mean here? Uniform will mean constant. But when we say constant circular motion, we are talking about the speed. Speed is constant. Clear? Okay, that's good. So now we will go into speed. How to find out speed? We know that what speed is? Distance by time. Speed is distance by time. So again, if I take one complete circle, if an object is starting here and it goes along the complete circle and comes back to A. So for one full circle, what will the distance be? Distance is length of the path. For one full circle, the path is nothing but the circumference. So distance will be equal to 2 pi r. And what do you call the time as? Time, we call it as time period. What is time period? Time taken for one complete rotation, one complete circle. So one full circle, distance is equal to 2 pi r. Time, we just call it as capital T, or time period. So you got distance, you got time. So what will speed be equal to? Speed will be equal to distance by time, 2 pi r upon time period. It will be equal to what? 2 pi r upon time period. So that's what we are talking here. Okay. So the time taken to complete one circular motion is called as time period. So this formula is applicable where? For one full circular motion. And using that we get what? We get speed. Okay. But ultimately what is the formula for speed? Distance by time. From that we get circumference by time period. But remember, the formula for speed is distance by time. So in uniform circular motion, get the speed, get the time, divide them, you will get speed. Get the distance, get the time. Distance by time is speed. Okay. And then you have centripetal acceleration. What does this mean? In circular motion, we talked about speed, 2 pi r by t. We talked about uniform circular and non-uniform circular motions. We talked about velocity, its direction. Now we'll talk about acceleration. Now how will the acceleration be? So in uniform circular motion, not in any other motion, in uniform circular motion, the circular motion in which speed is constant but direction of velocity changes, the acceleration will be along the radius and towards the center. So it's something like this. If I take it at this point, the velocity is along tangent, but acceleration will be along radius towards the center. And this acceleration is called as centripetal. Centripetal will mean towards the center. Okay. So this acceleration is called as centripetal acceleration. You can take at different points. You can take it as, let's say if I take it at B. At B, velocity is along this way, along the tangent. And you can see acceleration is along the radius, but towards the center. Here also, here also, here also. You can take at different points, that's what we get. So a very simple point. The acceleration direction will be what? Just remember that along the radius towards the center, and it is called as centripetal acceleration. So now from where did this come from? Is there a derivation for this? Yes, there is. But is it required? No, not required as of now. You will learn that much later on. In fact, when we go into Newton's laws, Newton's second law, then you'll understand it clearly. We'll discuss it again there also. But for now, remember the direction for centripetal acceleration will be along the radius and towards the center. Okay? Okay, that's good. So here let's come back to the question here. Is the direction of acceleration constant in uniform circular motion? Yes or no? What do you think? Is the direction of acceleration constant in uniform circular motion? And the answer is no. Why? Because again, if I take a circle, we know that in circular motion, in uniform circular motion, acceleration is along the radius towards the center. That means at point A, it is something like this. But if I take point B, it will be like this. Are the two directions the same? No, they are not. If I take a point here, it is along the radius towards the center, right? See, I'm taking different points, and you can clearly see at every point the direction of acceleration is different. Here it is downwards, here it is upwards. Here it is slant, here it is towards right, here also slant. So it depends on the point. So direction of acceleration also keeps changing, which means acceleration is not constant, because acceleration is a vector. Okay? Okay, that's good. So we have one more question here. We'll just do it and let end the class after this. A stone is rotated in a circle of radius 1 meter in a time of 2 seconds. What is the speed of the stone if the speed remains constant? If the speed remains constant, it is uniform circular motion. Just imagine this. If I draw a circle, a stone is rotated in a circle of radius 1 meter. So the radius is given as what? Radius is given as 1 meter. In how much time? In a time of 2 seconds. In a circle. So for one circle, the time taken is 2 seconds, or I can say time period is 2 seconds. So for one circle, what is distance equal to? For one circle, distance is equal to circumference 2 pi r. Time taken is equal to time period 2 seconds. So if I need speed, I will go for distance by time. So it is 2 pi r by 2. But what is pi? Pi is 3.14. What is radius? Radius is given as 1. Time is 2. It will be 3.14 meter per second. Why 3.14? Because you can see 2 cancel. What will remain? Yeah, 3.14 or 22 by 7. You can take it in decimals or in fractions. Okay? Simple, right? Get distance, get time, use the formula, you'll get the answer. Okay? Okay, so that's it everyone. We learned about circular motion, the velocity in circular motion and direction of acceleration in circular motion. So thank you, thanks a lot.